So thank you again, Zach, for coming out today. And thank you everyone else for joining us for the introduction to Chainlink and hybrid smart contracts. And today we have Zach, who's going to take the lead.
Awesome, man. Appreciate the introduction, Ben. Super excited to be here. I see we got a cool group of people here. So let's go ahead and dive right in. Okay, we're all good on the screen share?
Looks good.
Awesome. All right. Yep. So today I'm going to go over an intro to Chainlink and hybrid smart contracts. We're kind of going to build up to the Oracle problem and how Chainlink solves it and connect to hybrid smart contracts and the various products that are offered in the Chainlink ecosystem. Yeah, so it's going to be a fun talk. So a little introduction. My name is Zach Ayash. I'm a developer advocate at Chainlink Labs. A lot of people aren't familiar with what a developer advocate is. So a developer advocate is someone who helps engineers and anyone building with a technology be successful and make sure they have an awesome developer experience. So in this case, the technology is the Chainlink protocol. I followed Chainlink since 2017. I've been a big fan of the project because they're solving a really interesting and difficult problem in the blockchain space. And I kind of was involved with the Reddit community, just various online communities at the time. And in 2019, the Community Advocate Program opened up, kind of became a member of that program. And at the same time was teaching myself blockchain programming. And earlier this year, I landed myself a role as a developer advocate, where I've been since, and it's been an awesome time. All right, so today's plan, like I said, we'll build up to what is Chainlink. We'll discuss DeFi and how Chainlink relates to that. We'll talk about Chainlink beyond just price data, go over some resources where we can learn more, and we'll go over a quick demo. And if there's any time left, we'll open questions at the end. All right, so we'll go ahead and go into what is Chainlink. Well, before we go into what is Chainlink, you need to know, of course, what is a blockchain. I know a lot of you may be familiar if you're coming to this presentation, but just in case there's some people who don't know what a blockchain is. A blockchain is a highly secure, reliable, and decentralized network that stores data, exchanges value, and can record transaction activity. Basically, you can think of it as this network of computers all around the world that store data and transactions in a shared ledger, right? So this is like replicated database, replicated by many node operators all over the world. And because there's so many people replicating it, it isn't controlled by one person. Now, Bitcoin is known popularly as the first blockchain. And it's used to store and transfer value. But blockchains can do more than that. They can run application code. So for example, Ethereum has the Ethereum virtual machine. And we'll kind of dive into more details on that later. And also, we got to understand what is a contract. So a contract can be defined as a binding agreement between two or more parties, or a legal document that represents that agreement. And they started out written on stone and paper and things like that. And today, most of our contracts and agreements are digital agreements. So the storing and executing agreements are done on computers over the internet. And whether you realize it or not, most of the agreements we deal with today are digital agreements. Digital contracts really have been how we do most of our contracts for the past decade. From bank agreements to social media to products like Netflix and crypto exchanges, digital agreements all underpin these services. So as an example with the Netflix, right? Netflix charges $12 a month, and in return, their agreement states you have access, 24/7 access to their digital library of streaming videos, right? So all the various shows that they have. Another form of digital agreements you may be familiar with is finance agreements, right? A lot of financial services are now over the internet, and so digital agreements back them. These finance agreements tend to work when things are great, but when the market conditions get a little hectic, they may not work so well. So you may or may not be familiar with Robinhood. Robinhood is a equities exchange application. So you can exchange things like stocks. And they kind of had a digital agreement that people thought they understood, which was that users could buy or sell equities anytime that the market was open at their preferred conditions. So a bunch of users decided to exercise this digital agreement all at the same time and wanted to buy GameStop stock. Well, it turns out that Robinhood had vested interests that incentivized them not to enforce the digital agreement equally for all their users. And they actually blocked their service from a lot of users, so they could not buy the GameStop stock. A lot of users were angry that they did not get the contract enforced like they expected it to be. And really, this ended up benefiting the wealthier users of Robinhood. So we really can't expect centralized finance and these digital agreements that back it to support the average user all the time, and oftentimes when they need it the most. So in comes smart contracts. So this is the next level of digital agreements. Smart contracts are self-executing code that execute without the need of a third party. Really, you can think of Bitcoin as a really basic smart contract, but the code only allows the transfer of value. Ethereum came around in 2014 and kind of generalized that and allowed any form of smart contract to be built on top of it. And now smart contracts today can be built on a variety of different blockchains. And typically when we say smart contracts, we mean the self-executing code that is built specifically on blockchains. So what makes smart contracts superior to digital agreements? Well, one thing is security and tamper-proofness. It's very, very hard to hack a blockchain. And blockchains like Bitcoin and Ethereum have been live for many years now without any incidents at the protocol level. Once you deploy a smart contract, and it has been reviewed, you can see how long it's been live since everything is public, and decide for yourself if that contract is secure. Reliable and guaranteed execution. So traditional agreements need to be enforced by someone, right? You need, typically when two parties have a contract, there's a third party enforcing it. A lot of times that may be all the way up to the governmental level, or could be escalated to that level. As an example, Robinhood, right? So there was an agreement between the users and the market makers of those stocks. And Robinhood was kind of the intermediary enforcing that contract. So with blockchain, we kind of remove that intermediary and allow reliable, guaranteed execution. Transparency. So many smart contracts are transparent by default. This helps alleviate issues such as the 2008 financial crisis, which was really caused by this opaque system where it was hard for people to see exactly what they were getting when they were buying these junk bonds and such. Trust minimization. So again, kind of with the guaranteed execution, you don't have to rely on someone to execute that code. It is kind of self-executing in this decentralized way, so it could avoid issues like the GameStop and Robinhood debacle. And efficiency. So really what we're doing with smart contracts is we're automating all of this code. And that brings about lots of efficiencies for organizations that would like to do this. Think about all the teams that are at, the banks and Robinhood that are just there to make sure that their contracts are executed properly and without legal issues. This could save them a lot of money. So, blockchains and smart contracts are awesome. They have these awesome properties. But turns out that smart contracts, at least as originally envisioned, weren't as smart as you may think they were. So there's an issue where smart contracts cannot actually access data from the outside world and bring it into the blockchain. This is a big limiting factor for what you can do with smart contracts, right? And so to kind of understand why this is a problem on blockchains by default, you have to understand that blockchains are deterministic, right? So all the nodes that are running this blockchain software, they have to come to consensus on the data that is being going through the database. And so you can kind of see in this diagram down here, you have on the left side, the deterministic good blockchain coming to consensus, just running a simple calculation. And these nodes are spread out across the world and communicating to come to consensus. Well, on the right side, you have a blockchain that is hard-coded to connect to a specific API, right? So it queries, like, let's say, CoinGecko's API to get price data for ETH USD. And this node at the top may query and get one number, and this node queries a couple of seconds later when it gets the order to and gets a different number. Now these blockchain nodes can't reach consensus. So this is the smart contract connectivity problem, right? So blockchains aren't able to effectively connect to the outside world on their own. They're basically stuck validating value transfer and ownership of tokens without some other sort of mechanism or middleware. So what's the solution to this? You have a blockchain oracle, right? An oracle is that middleware. It is a mechanism that allows a blockchain to connect to the outside world and communicate with it. For example, they can report the result of off-chain data, such as prices like we saw in the previous example, and report them so that the blockchain can stay deterministic. Now, here's the thing. We could make a simple oracle, make it go through one node and report data through one node, but a centralized oracle really is a single point of failure, right? For an entire smart contract. And remember, what made smart contracts so awesome was their decentralized nature. If a single node or entity controls the oracle, they can be corrupted, they could be bribed, they could be hacked. So we don't want just any old Oracle middleware. What we want is a decentralized Oracle middleware, right? And this is what Chainlink is. It's designed to be a modular, decentralized Oracle network for connecting smart contracts to off-chain, off-blockchain resources. So in this example, you can kind of see a picture of Chainlink nodes all coming to consensus on price data, and then posting that price data on chain as one transaction, allowing the blockchain to stay deterministic. And so that really brings us to now the concept that we're really trying to explore, hybrid smart contracts. So smart contracts that are composed of both on-chain and off-chain resources. Previously, they were just thought of as code that lived on the blockchain. Now we're kind of rethinking what smart contracts are. And really, you're going to find that now that you can connect your smart contracts in a secure, reliable way to off-chain resources, really the ideas that you can develop with smart contracts are limitless. So we'll go into one specific area where people are using Chainlink, and that is DeFi. So you may or may not be familiar with DeFi. DeFi stands for decentralized finance. And it is essentially taking that logic, those digital agreements for all the financial applications that we were talking about earlier, and making them smart contracts so we can get all those cool and and very useful properties. So you can think of a lot of smart contract applications or DeFi smart contract applications like borrowing and lending and decentralized exchanges. These are some really popular initial DeFi solutions that we've seen. But Chainlink specifically helps DeFi by providing off-chain data on-chain. So many of these borrow and lending applications, for example, require off-chain data to operate properly, right? So if you are borrowing and lending ETH, the native currency for the Ethereum blockchain, these applications need to know what the price of ETH is versus another currency like ETH USD or ETH versus Bitcoin. And so Chainlink offers what we call price feeds to get that data on chain. So in these price feeds or data feeds, each node in the network independently gets data from some of the highest quality APIs on the market and aggregates them at the node level, and then aggregates it within that network of Chainlink nodes that I showed previously, and reports all of that data on chain. Many of the most popular cryptocurrency pairs are currently supported, and to support this decentralized nature, all of this code is open source, so anyone could access the code to these data feeds and see how they're working, and even spin up your own data feed if you're interested. You can learn a little bit more and see all of this in action at data.chain.link. You can see most of our price feeds in the different blockchains that they're live on. So what makes these so important, right? Projects that have used non-decentralized price feeds in the past have been the focal point of attacks or hackers in a way. People who have found that, hey, if you are relying on a single oracle, I can manipulate that oracle in my favor and take a lot of money out of your protocol, right? Millions of dollars have been lost this way. And so that's why Chainlink goes to such extents to make sure that all of the price is aggregated properly at the node level and between the node level. So DeFi is really growing fast. Lots of projects are still coming up every day. There's just tons of momentum and a lot of really smart people working to solve interesting problems. This photo of some of the top DeFi protocols was taken back at the beginning of June. So this is all, already slightly out of date. But really, almost most of these projects that you can see are using Chainlink in some way in their protocol to get price data or more. So some popular DeFi protocols that are using Chainlink, you have Synthetics, SushiSwap, Set Protocol, Aave, and most recently we had Compound, which was the #1 on that list earlier, switched to using Chainlink because of that said vulnerability. They were actually using a more centralized Oracle solution, and it was the center of an attack for them. So you can always learn more about price feeds at our docs website. We'll be using them a bit in the upcoming demo. But yeah, I really suggest you go to docs.chainlink if you would like to learn more. So let's talk a little bit about Chainlink beyond price data. Chainlink is increasingly pushing to not just bring price data, but all kinds of different data onto the blockchain. And one type of data is randomness data. So randomness is actually a very, very difficult type of data to bring onto a blockchain natively due to that deterministic nature of blockchains we discussed earlier. So Chainlink offers the Chainlink Vrf, which provides provably random data to blockchains. You send a request and you get provable randomness back from the Chainlink network. And so this is being used in a lot of different ways, but one popular area we've seen it being used is in gaming and NFTs. So a lot of NFTs want to guarantee their users that they were minted in a random way. So they send requests to the Chainlink VRF to generate provable randomness for them, and can assure their users that, hey, yeah, you do have a 1 in 1,000 chance of getting this one specific NFT. Or they can use it to generate the metadata for the NFT, the properties of that NFT in a decentralized and provably random way. Another thing that Chainlink has been venturing into recently is the Chainlink keepers. So an interesting property about smart contracts is that they cannot execute their own code without an external actor initiating that execution. So Chainlink keepers allow smart contracts to execute their code in an automated and decentralized way. So as an example, the Aave protocol could use the Chainlink keepers to decentralize the liquidation of their loans, right? So to get better guarantees that their loans will be liquidated when they should be, they can send a request to the Chainlink keepers, say, anytime that loans fall below a certain value, we need you to come in and liquidate those loans for us. And that request is sent to the Chainlink keepers, who monitor the network for those conditions to be met and can execute them. So we'll actually be going through a really basic Chainlink keepers example in a bit. So where can you learn a little bit more about Chainlink? So of course, as I said earlier, the docs is a great place to go. They're a fantastic place to learn anything about developing with Chainlink. I really recommend following the tutorials we have. So we have tutorials all the way from a beginner's level to advanced, and they can really bring you from 0 to hero on Chainlink if you follow them. And the docs are now open sourced as well. So if you are going through the docs and you see something that you think could be done better, or some typo, or anything you'd like to contribute, feel free on a GitHub. Also, we have our blog. So that's a great place to see how-to tutorials, general explainer blogs that may be too long for the docs, and a great place to go get project ideas. If you're thinking, I can't think of any project ideas on how to project ideas for like a hackathon, that's a great place to go. A specific blog to check out would be the 77 smart contracts use cases. That's a great blog if you would like to get some of those project ideas. There's just so much that you can do, from gaming to insurance to DeFi. So really recommend checking out this blog if you're kind of struggling to think of some way to use hybrid smart contracts. And for those of you that are more video focused, we have our YouTube. There's Chainlink engineering tutorials and developer workshops you can find there that we've done from various places. I personally like to watch videos a lot of the time, take that mental load from reading articles all day. So highly recommend checking out the YouTube. And finally, we have our starter kits. So if you're interested in developing locally using Truffle, Hardhat, or Brownie, which are all very popular smart contract developing frameworks, check out our starter kits. So we've already preloaded them with all of the basic smart contract, Chainlink smart contracts that you can find in our docs, some basic tests, a lot of interesting scripts you can run to make your development life easier. And again, this is on our GitHub, so all open source. You can contribute to the code if you want, and we'd love to see that. All right, so that's kind of an introduction to Chainlink and the problems it solves. So let's do a quick demo on using Chainlink. So today I'm going to walk through keepers and price feeds, and we're going to use them with the web-based IDE Remix. So some things I have installed already: MetaMask wallets, one of the most popular wallets for interacting with the Ethereum blockchain. I'm going to have some testnet Ethereum in MetaMask, specifically Kovan ETH, and some testnet Link, also on Kovan. There's some links where I got them. And we're going to go ahead and start with keepers. And we'll go ahead and go to the docs. Okay, so now that we're in the docs, we want to use keepers. So we're going to go to scroll down on the left toolbar to where it says using Chainlink keepers and click making compatible contracts. Now remember, what made keepers so useful and awesome is that contracts cannot execute the code on their own. So what we're trying to do is we're trying to automate the running of specific smart contract functions at specific times or when specific criteria are met. So when you're developing a smart contract using keepers, you just need to make sure that you follow the compatible interface. So it needs to have a check upkeep and perform upkeep method in it. We'll go ahead and go in a little bit deeper once we get the code up. So if you scroll down a little bit, you'll see an example contract and a button that says deploy this contract using Remix. So we're going to go ahead and click that button and open up Remix. All right, so here we have the gist, and the file we're looking for is counter.sol. I'm going to minimize that. So here's our example smart contract that uses keepers. You need to import the Chainlink package and import and have the Chainlink compatible interface here that I was discussing earlier. So we have a check upkeep and perform upkeep. And so this is going to be a really basic smart contract that uses keepers to increment a counter variable when a certain amount of time has passed. So here's our counter variable, an interval. So we're going to set this down below, but this will determine when the keepers are run, and a record of the last timestamp since keepers have been run. We have our constructor. This will initialize the contract when we deploy it, and we'll need to provide it an update interval in seconds on how long we want to pass before the keepers run. And then we have our two main methods, check upkeep and perform upkeep. So check upkeep is run virtually at the Chainlink node level. So it's not actually being run on the blockchain. So you can actually put really complex code here and not have to worry about gas fees, because the Chainlink nodes, keeper nodes will not run it. And basically what this method will do is check to see if the keepers actually need to run. And the next method, perform upkeep, once check upkeep returns a true, for instance, says, hey, yeah, we need to go ahead and run our upkeep, perform upkeep will run. And that's where you put the actual logic you want the Chainlink nodes to run when they perform their upkeeps. All right, so now that we kind of got an understanding of how this keeper contract works, we'll go ahead and compile it. Looks like it's compiling all right. Now we're going to deploy it to the Ethereum blockchain. So we're going to switch it to injected Web3. This tells it, hey, I need to connect to my MetaMask to connect to the blockchain. So it is connected, showing Kovan. And we're going to make sure that this is pointing to that counter contract that we were discussing earlier. And right here beside the deploy button, you'll see that it requires that update interval that goes in the constructor. So before we deploy, we have to tell it, hey, how long needs to pass before the Chainlink keepers need to run? So we're going to go ahead and put 2 seconds there. So this is going to run every 2 seconds. The keepers will run on the contract every 2 seconds. We'll hit deploy, and we'll need to pay some gas fees, hit confirm. And as soon as this is included on Kovan, we should see the deployed contract appear on the left. Yep, there it is. So our transaction has gone through. Covan. I'm going to copy this. We could interact with the contract here. We don't need to because we'll be letting the keepers do that. But yeah, copy that address. We're going to use that in a bit. So we have a contract deployed to the Covan network that is going to use the keepers, but how do we register that contract so the keepers know it exists? So again, we're going to go back to the docs and go to using Chain Link keepers. And this time we're going to go to register upkeep for contract. See, I will want to note that all of this is in beta. So we're still kind of working out all of the UX and UI. If you ever have any suggestions on how to improve this, feel free to let us know. Make some issues on the docs repo. We'd love to hear it. So I just clicked on real quick the Chainlink Keepers website. So this will take us to the website where we can register our deployed smart contract so the Chainlink Keepers know it exists. To register for Covan, you don't actually need to sign up for anything. You just need to click on register new upkeep job, and you can begin filling out this form. So we're going to go ahead and fill it out. I'll type in my email, so zach@smartcontract.com. It's a little bigger so people can see. And remember how I copied that deployed contract address? We're going to paste that in right there. The admin address is the address of my wallet that I'm talking to Covan with. So yep, it matches. I can look at the first couple of characters. And now the gas limit is important. We need to tell them what the gas limit for this execution is. And that's how they'll kind of dynamically determine the pricing of each keeper request. For the counter contract, the docs recommend a gas limit of 200,000 GUI. Now this gas limit, it should be for the max gas limit you expect that code, that method to cost. And we'll need to determine a starting balance of Chainlink tokens. So the keeper nodes are paid in Link token. And we'll go ahead and start it with 30 Link. So there is a minimum balance that needs to be set to run Chainlink keepers. We're going to do 30 to be safe. And click all our checks. And now we're going to register our upkeep. Oh. Put my upkeep name in put my email address in upkeep name. So we'll put my email in the right field and we'll call this counter test. All right. Now we'll register the upkeep. MetaMask pops up again. We'll confirm the transaction. So all this registration is done on chain to keep it decentralized. And our upkeep registration request was submitted successfully. So we can view the upkeep. Here we go. We have ID 181. It's active. You can see our current link balance and our address for my wallet. So it takes about 10 blocks for the keepers to see that the upkeep was registered. So if we go back to Remix here, it still won't have run quite yet. If we check the counter, oh, it did run. So our counter has already been incremented at 1. So that means the keeper saw it. The variable was initiated at 0 and should continue to run every 2 seconds. And we see that the balance has also gone down accordingly to pay the keepers. So you can really automate anything this way. The example early, liquidations of loans, maybe you want to have a contract be topped up with funds. Yeah, there's kind of an unlimited design space with these. And I'm really excited to see how teams use this. And yeah, you can kind of see the balance continuing to decrease in real time. And real quick, I also wanted to show price feeds, since many people are interested in using price data in their smart contracts. So here, back in the docs, I'm going to click on get the latest price. using price feeds. And we'll scroll down and we're going to deploy once again this contract using Remix. So we'll click this button. All right, pull it up in Remix. And this time we're going to open price consumer v3.sol. So here we have the price consumer contract using that utilizes the price feeds. Well, again, we import the Chainlink packages at the top, and this contract is titled price consumer v3. In our constructor, we're going to set this variable price feed to point to the ETHUSD price feed on Kovan. And we just have one simple method, get latest price. So we'll go ahead and compile it. No issues or so. We have one compiler issue here. Yes, this is because our GitHub changed the structure recently. So actually we can go to github.com and we can search Chainlink. Awesome. So this is the Chainlink GitHub repo. We can go to contracts to see all of the latest smart contracts. This is all publicly available. We'll go to source. We're going to use the V6 contracts. And we will go ahead and import these. Oh, it's not throwing any errors anymore. Okay, decided it could find it. Sweet. Oh, this is the keepers. Sorry. Here we go. So put this here. Still not finding it. We should be able to take this one and post it over. I'm not sure why it's not finding that. We'll have to figure that out. But yeah, so that's the price consumer contract. Essentially what I was going to do is deploy it, and you'd get a button over here where you just click get latest price, and it would pull up the latest price of ETHUSD. Definitely have to figure out why that isn't coming up. Hold that whole thing. All right, hold on. I think I got it to work. Sweet. If we compile it real quick. Now we can deploy. Want to make sure we're on injected Web3 there. Deploy, confirm with MetaMask. Now we can interact with our contract, click get latest price. And man, we got the latest price of ETHUSD on the Kovan network. All right. Yeah, that was just an introduction to Chainlink and smart contracts with Chainlink. Just want to say thanks for developing with Chainlink and being a part of this hackathon. And thanks for having me. I'm really excited to see what cool things people build here, and people who use keepers, price feeds, VRF, all of the Chainlink solutions, and hope to see some world-changing smart contracts being built out of this hackathon. And the floor can be open for any questions if anyone has anything.
Thanks again,
Hey,
Zach.
Zach.
Go ahead.
Hey, how's it going?
Hey, Zach. This is Matt. I don't know if you saw on Dev or on Discord. I posted how I'd seen Sergey talk about the fact that basically this could be used to create governance in countries where there isn't governance, and to create essentially betting on data streams where there is no data stream or no place to do that. So my background is in computer vision. Yeah, when I heard that idea, I thought that's incredible. So I was wondering if you had examples of places where computer vision models are used as the inference data to govern smart contracts. And then the second question is about leverage, which I had mentioned, and about like fractional reserves. And basically the fact that the entire lending system and insurance system relies on trust in a fractional reserve of the total claims that could be made. And the fact that people with capital would not want to take the deal of putting the entire collateral up like every single time. And so if you have any examples as well of that stuff, because Sergey mentions it in a lot of his talks, this exact scenario, if there's some farmer in some country without a good justice system, and so no one trusts creating a contract, and what are like real world examples of how they solve those problems?
I think those are really interesting use cases of smart contracts. I think those are all still kind of in development. Those are pretty advanced, far off use cases. I do see that being a possibility. I mean, we're seeing the beginning of it with DAOs, right? Just decentralized autonomous organizations, just groups of people coming to agreement on how things should be run over the blockchain. And I could definitely see in the next couple of years that eventually trickling out to governmental level projects. I think it could be a lot of use there as well. But as for specific examples at this moment, there's nothing that comes to the top of my head. I just know a lot of people who are kind of working on these kind of issues. So
Sergey is the founder of Chainlink, right?
He is a co-founder, yes.
Okay, and you work for Chainlink, right? Like it's an organization. I don't know a lot about Chainlink.
Yeah, so I work for Chainlink Labs. So Chainlink is an open source protocol. So anyone can build and develop on it. It's all open source on GitHub. Chainlink Labs is kind of like the lead development firm that is building the Chainlink protocol, but it's open to anyone. So yeah, that's kind of the differentiation there. We're kind of running on time here.
Chainlink.
Does anyone else have any other questions? I'd like to give other people a chance if they do.
I have just one question. I'm pretty new to the space. My background's more in molecular biology, but I was just wondering, since it's all pretty much open, like to everyone, how would Chainlink Labs, I guess, how do you guys like support yourself or turn a profit? Is it like a transaction fee or just kind of licensing for your software? Or
yeah, I mean, Chainlink Labs kind of follows the open source model of monetizing its services. So I would recommend like kind of looking into the Red Hat and all of these open source Linux distributions and how they make money with open source software. It's pretty interesting. So
awesome, thank you.
Yep.
I have a question.
I see Sebastian has raised his hand, so I'd like to get to him.
Yes. Hello.
Hey.
I'm also new in everything is related to blockchain and also with crypto. And I was just wondering in terms of numbers, what budget should I expect in order to build a blockchain from scratch and also to implement crypto coins for my project?
So I definitely wouldn't recommend building a blockchain from scratch. Definitely utilize, I would recommend utilizing one of the existing blockchains like Ethereum, Polygon,
right. Yeah.
Anyone you want.
Polkadot.
Yeah, all of those are great.
I see. Yeah. So we just like collaborate with them.
Everything is open source. I mean, a lot of these projects have Discords. Like we have a Discord where a lot of the active engineers go and answer questions. I recommend going there, checking out their documentation.
I see.
Um,
So even if we would like to cooperate with you, maybe with Chainlink, I mean, we have to arrange a meeting and like present you our project. Or
You don't have to, no. You could contact to see, if you'd like to get some like collaboration or advice, but everything is open source, right? Like I said, if you go to our docs and you go to our GitHub, all the code is there. You should be able to get up and running without anybody giving you permission to do so. But of course, if you'd like to collaborate some more, you can always reach out to the team. Go to chain.link and there's a button to talk to an expert. Go to our Discord, go to GitHub, make an issue, all these things.
Okay, thank you.
I had a question.
How are we doing on time? Are we still good?
We have the hour booked up. I'm not sure when you had to go.
Okay, I'm fine
Okay,
to go through these questions then.
sounds good.
Yeah.
Let's try to keep it on topic to Chainlink, everybody, just so keep Zach what he knows.
Can you guys hear me?
Yeah, go ahead.
Hey, thanks for presenting today, Zach. So I had a question about the collaboration between Chainlink and the World Economic Forum. I was kind of wondering when that started, how close the teams are, and sort of what the future roadmap of that collaboration looks like.
So yeah, I'm not super familiar with that side of things, how they're collaborating with the World Economic Forum. I do know that you might have already seen it, but that paper was posted in December. So there's a collaborative paper between Chainlink Labs and the World Economic Forum, where Sergey works with some key collaborators on there. I'm not sure what the future roadmap is. I know Chainlink Labs as a whole is trying to collaborate with more like public good sector, like companies and services. So it's definitely something the Chainlink Labs company is still interested in, but I can't speak to what the future roadmap is on that.
Sure, cool. Thanks.
Yep, no problem.
Sounds good. We'll end it there. Thank you, Zach, again for coming in today. It's a great presentation. I'm sure Connor will be in touch to where the recording of this will be posted, as well as the deck from Zach.
Awesome. Yeah, thanks for coming out, everyone, again. It was really cool giving this presentation, and I'm just like super excited to see what people build. So yeah, let me know. Reach out if you need any help. Reach out on the Discord. Reach out on GitHub or Stack Overflow if you have any technical questions. We'll be there to answer them.
Thanks again, everybody.
Yeah.
All right. See ya.
Thanks a lot.